Okay, we have another half-life problem. We're given that the half-life of radium-226 is 1620 years. So again, 226 is the isotope name, so we're looking at just the half-life one only, 1620 years. And then it says how much of a 2-gram sample is left after 1,000 years. So this one doesn't ask us for the decay function, but we still want to find that one first anyway. We need to use that in order to answer the question here. First, you want to find your decay constant, your K value. So K equals negative ln2 over 1620 is the amount that was given here. That's your half-life. That's how long it takes for half of something to decay, would be that one. Now, if you put that into the calculator, this is what your calculator is going to give you for the answer. You may see something like this depending on what calculator you have. You get negative 4.2786 in E and a negative 4. Okay, so you want to make sure you don't make the mistake of making your K value negative 4.278. That's incorrect. Your calculator is giving you that in terms of scientific notation. So what that's telling you to do, the negative 4, that means you want to move the decimal place 4 places to the left. So in actuality, the K value you're going to use is this, negative 0.0004. You're moving it 4 places over to the left, and you'll get this as a result. So that's the K value that you want to use. You don't want to use negative 4.27. Your K value should always be some kind of decimal. It should be between like 0 and negative 1, somewhere around there. So negative 4, that's going to be way too big. This is more like the type of K values that you're going to see. We have this. Now we want to form our decay function. We were given that you originally start with 2 grams. So A of t is going to equal, if you do that, then you're going to get your original amount was 2. You have e to negative 0.0004 t. This right here, I'll make this a little bit darker so you can see it on the camera there. A of t is equal to 2e to negative 0.0004 t. This is your growth function for this particular one. It's specific to this particular problem because we're starting with 2 grams, and we have a special K value that's specific to this particular half-life, 1620 years. Now we can answer this question. How much of a 2-gram sample was left after 1,000 years? So to solve that, they really want you to put 1,000 in for the time. This is 2e to negative 0.0004, and then times 1,000. You have that in the exponent position. When you do this, you're going to multiply by 1,000. That's going to move the decimal place over 3 places. So when you multiply that, what you'll get on top, so you want to always do the exponent part first, you're going to get this, negative 0.4. Move that one over to here. Now that we have this, we're going to put this part into the calculator, and that's going to allow us to get our final answer. So A of 1,000, again that's our function notation, A with 1,000 put in for t. If you put that in there, you're going to get about 1.34 grams. So again, you can check that on your calculator, and usually the problem will tell you what to round to. My default, I usually just use 2 decimal places if none is given. This would be your answer there. So after 1,000 years, we still have 1.34 grams left. Of course, if we went all the way to 1620 years, that means that we'd only have 1 gram left because it would be half of what we originally started with. So we're not quite at 1620, which makes sense that we should have a little bit more than 1.